We'd like to thank the following sponsors.
Hello, and welcome to this Glass Build Connect session on developing a test plan for fenestration products to demonstrate compliance with applicable building codes and standards. My name is Jeff Inks, and I'm Vice President of Advocacy for the Window and Door Manufacturers Association, and we are very pleased to be a part of the Glass Build Connect virtual conference and to bring you this session. Here to make the presentation is Rhonda Schotz, who is the Commercial Manager for Building Envelope Sciences at Underwriters Laboratories. Rhonda has nearly 30 years of experience in window design, certification, fenestration testing, and quality systems management. At UL, she works closely with the Building Envelope Business Director and sales managers focusing on account development and growth, expansion of UL services, customer satisfaction, and sustaining customer loyalty for building envelope related customers. Included in that experience, Rhonda also served as the certification administrator and technical liaison for WDMA certification activities when she was with Administrative Management Systems Incorporated, better known as AMS. And she played a key role in creating and implementing the client information portal for manufacturers to manage and track their certification for the National Fenestration Rating Council and WDMA's Hallmark certification programs. With that, welcome Rhonda.
This presentation is intended to provide the user with the background and guidelines on the creation of test plans for the fenestration industry. Manufacturers want to qualify the maximum number of product options and configurations using the minimum amount of test specimens. Some of the learning objectives of this presentation are to share knowledge with the industry about building codes and standards, help the industry gain knowledge about creating test plans, and to connect the industry participants together from the creation of the test plan, submission for approval, testing of their products, test report submission to third-party certification agencies or state approval agencies. The main ideas to take away from this presentation are to familiarize yourself with the codes and standards, to learn about the performance requirements within the standards, to outline testing goals you hope to achieve, to define objectives of what you will or will not need to test, to create your final test plan for submission to your third-party certification agency, to obtain a test report from a third-party testing laboratory, and finally, to submit your test reports to your third-party certification agency. States adopt these model codes, and they can also amend these to meet their own specific requirements. Model codes list performance requirements for product-specific performance criteria. The performance criteria lists the test standards to test to for each product. Requirements are mandated by building codes, federal agencies, architectural specifications, and building owner requirements. Some of these are the IBC International Building Code, the IRC International Residential Code, Florida Building Code FBC, Miami-Dade Building Code, Federal Emergency Management Agency, also known as FEMA, and the International Code Council. On this chart from the International Code Council, you can see which state has adopted which version of the building code. I have attached a link to the website it is referenced from. This is a helpful guide to getting you started in creating your test plan, knowing your market area. So within each of the building codes, it references the standard which your product needs to be tested to for meeting their performance requirements. As you can see on this slide, in the International Residential Code, it references the NAFs, ASTM E330, ASTM E1886 and 1996, and the WDMA IS11. Per the ICC 500 shown here, it has its own set of requirements as well. This is typically for storm shelter windows, doors, walls, and roof components. In the Florida Building Code, or FBC, in Miami-Dade, it references the NAFs, ASTM E330, TAS 201, 202, 203, the AMA 506, and the ASTM E 1886, 1996, as shown on the screen. The Federal Emergency Management Agency, otherwise known as FEMA, has publication 320 and 361, which are for safe rooms only. Just a note that FEMA does not regulate, approve, or certify products or set standards for building codes. So within each previously mentioned building codes and agency requirements, these are some of the test standards which were referenced. In the Florida Building Code, Chapter 35, Reference Standards, it lists a variety of standards to test your product line for. Notice that the current 2020 Florida Building Code now does reference the NAF 17. The two links at the bottom of the screen are for the Florida Building Code Chapter 35 Reference Standards and for the Florida Residential Code Chapter 46 Reference Standards. It is a good idea to review these sections before deciding which version or year of the test standard to test to. To outline some of the testing goals, you must ask yourself, where do I start? Well, here are some options. What market area are you trying to get your product tested for? Is it Florida, Texas, Canada? What building code requirements am I trying to meet? Is it the IBC, IRC, FBC? Which test standard within each of those building codes do I need to test my products to? Is it NAFs, ASTM, AMA requirements? Note, the current building codes will accept the latest versions of test standards most of the time. Check with your AHG or authority having jurisdiction. How many test specimens are required? Each test standard will list the requirements of how many test specimens are required to comply with the standard. But listing agencies may sometimes require additional specimens. For the NAFs, it's usually typically one test specimen. For ASTM E 1886 and 1996, it's typically 3 identical specimens. And for TAS protocol, see Miami-Dade website link listed above for information in regards to quantity of units to test. And then finally, what type of products do I want to test and get certified? There's a variety of types of units. There's awnings, hoppers, casements, projected, side hinge doors, etc. As shown here, each test standard requires you to select the performance you are wanting your product to achieve. So for NAFs, there's a performance class of either R, LC, CW, or AW. There's also performance grades, which is the design pressure, or PSF, of 20, 25, 30, 35, etc. Those run in 5 PSF increments. There's also the WDMA IS-11, which is an analytical method for design pressure. There's interpolation and extrapolation. AMA 450 gives you 3 options of getting a rating for your mullions. You can test the total assembly configuration, or option 2 is testing the mullion elements as individual components, or option 3 with structural calculations by PE. Also, ASTM E330 is used for structural performance only. Again, you need to know what design pressure you want your products tested to. For ASTM E1996, you will need to choose what design pressure and what missile level you want to choose for the impact portion of it. There are missile levels A, B, C, and E. And finally, for TAS protocol, for the structural portion, that's air water structural portion for TAS 202, you will need to decide what design pressure to use for that. For TAS 201 and 203, that is your impact and cycling portion of it. Again, what design pressure and what missile level you are wanting to use. In the previous version of NAFs, a gateway unit would have to be tested first to qualify that product before a larger unit could be tested. Now you can test a larger unit as long as you meet the minimum gateway performance grade or design pressures for air, water, and structural performance. Note, for purposes of compliance with either ASTM E1996 or AMA 506, specimen test sizes shall not be restricted by the gateway requirements of the standard specification. These sections of NAFs pertain to not only testing rectangular units, but the possibility of combining shapes into the test units as well. See figures shown on the right side of the slide, taken from NAFs. Also review the WDMA's CS3 G1 in the general section. Testing of one shape covers any shape that can be circumscribed within the tested shape, providing the framing, sash, hardware, components, and construction remain the same. This applies to air, water, structural, and impact testing. Referenced in NAFs 1117, sections 12.3.2. These are not meant to be all-inclusive. These are just recommendations. Many times the question is asked, can extruded aluminum qualify a wood product? The NAFs doesn't really go into any detail about this, but the WDMA CS3 indicates that testing of prime covers testing of clad as long as the cladding is not structural, which includes extruded. See the example illustration showing that extruded aluminum is considered a structural component due to it holding the glass in place up above. When testing combination assemblies, some individual units can also be qualified. Note NAF section 4.6.3.2. If tested as a combination assembly, the individual units making up the combination assembly shall also qualify as individual units within the unit width and height less than or equal to individual test unit size, provided that the individual unit also complies with clause 4.4.2.5, which is the minimum size tested. The sections that pertain to this in NAFs are listed and some examples are shown in the figures to the right. Again, these are not meant to be all-inclusive, but just recommendations. Please review WDMA CS3 M5 for combination assemblies. Manufacturers shall provide diagrams of test configurations and shall provide hallmark certification numbers for gateway tests if an individual product in a combination assembly does not meet gateway. This section of NAFs discusses the use of tested glass thickness versus production glass thickness requirements. Basically, all glass for test units should meet the ASTM E1300 guidelines as referenced in section 10.2 of the NAFs. If a manufacturer tests with a stronger glass than what is shown in the E1300 and passes the test, then they would be required to also use that strength or stronger glass in their production units. By testing per E1300, the manufacturer could then use a thinner glass for lower performance when needed. This saves the manufacturer a great deal of cost. Make sure to read this full section because there are some exceptions that apply. Per NAFs, when trying to qualify multiple anchorage methods like installation masonry clip, screw-through frame, or nail fin, section 9.2.5 note is critical. The laboratory test protocols are intended to permit the performance evaluation of the fenestration product alone, rather than evaluating the performance of the installation. Also review WDMA CS3, item S5. In designs where these differences are in question, in addition to the engineering rationale, one additional unit shall be tested to adequately evaluate the potential differences in installation methods for structural, air infiltration, and water penetration performance. For the ASTM E1996 test specimen requirements, you should always remember that a product needs to be tested to NAFs first. Once that initial product is tested, then follow the ASTM E1996 rules on test specimen requirements. As noted here, 3 test specimens shall be submitted for small missile as well as for large missile. The size of the specimens should always be the largest size that you would like qualified. When trying to qualify multiple glazing options for your product, make sure to review these sections about substitution allowed and which substitutions are not allowed. Example, if testing is performed with insulated impact glass and you would like monolithic qualified, that is not allowed per section A1.8.4 of the ASTM E1996. But the WDMA CS3 Item I-19 states changing from annealed to heat-treated glass on the sacrificial light, if it is not part of the structural attachment, is allowed. The image in the lower right corner shows monolithic glass, insulated glass, and triple glazed glass. Per ASTM E1996-17, when trying to qualify multiple anchors methods like installation masonry clip, screw-through frame, or nail fin, section A1.3.5 is critical. Each method of anchoring shall be qualified by testing a single specimen in the condition that produces the greatest load on the anchoring method, or qualified by engineering analysis. So when testing 3 identical specimens, frame, sash, glazing, hardware, etc., you are allowed to have different anchorage methods for all 3 specimens, as long as they meet the greatest load on the anchoring. The older versions of ASTM E1996-14, section A1.3.9.3, did not allow multiple anchorage methods on the 3 identical specimens in the past. The image in the lower right corner shows installation masonry clip method, screw-through frame method, and nail fin installation method. This section of the ASTM E1996 talks about material substitution and what can be changed out without additional specimens. But of course, there are some rules that apply. Section A1.12.3, any substitution in the material of the framing, sash, panel, or door leaf must maintain the same glazing design, detail, and glass bite as originally tested. The image on the right shows a triple glazed unit and shows the glazing design detail. So if you wanted to make your frame and sash with a deeper from 1 3/4 to 2 1/4, you must maintain the same glazing design, detail, and glass bite as originally tested. When testing combination assemblies, some individual units can also be covered. The section that pertains to this in ASTM are listed. Also, per the WDMA CS3, some minimum requirements need to be met. Per the M3 section, if units are mulled together, the mullion must be qualified to the rated wind loads of that unit. The units or mullions may be rated under IS 11 or AMA 450. Item M4, each product with a combination assembly or a composite unit must meet the minimum requirement qualifications for that operator type and the stated design pressures, including the gateway size requirements. And M5, for combination assemblies, manufacturers shall provide diagrams of the test configuration and shall provide hallmark certification numbers for gateway test if an individual product in the combination assembly does not meet the gateway. Per ASTM E1996, these sections apply for the hardware substitution rules. If a manufacturer wants to test for multiple hardware options, then 1 additional specimen with that hardware changed out is required for testing. Example, testing a side hinge door with 4 butt hinges, and you test and qualify that with your 3 identical specimens, and now you would like to qualify a side hinge door with 4 adjustable hinges. This would require 1 additional test specimen to be tested. Also, don't forget to test 1 additional specimen per NAFS to have it qualified there as well. And then finally, per CS3, item I-10, the structural portion of air-water structural testing should be used to validate the hardware performance with regard to the number and location of hardware. Impact testing should then be done on the largest size and shape and type and quantity of corresponding hardware configurations. These sections of the ASTM E1996 explain which elements of your products can or can't be substituted after the 3 initial test specimens have passed all the requirements. Make special note that section A2.3.3, any substitution shall be allowed for materials and components only after a minimum of 3 out of the 4 initial specimens have passed the prescribed performance requirements and are identical in every way, including anchorage and mounting. Example, when submitting impact units for testing, Unit 1 can be used for air-water structural testing, as well as the 4th backup unit for impact testing and cycling, along with the 3 identical specimens for impact and cycling. Also note section A2.3.4, any substitution shall be qualified at a pressure equal to the design pressure at which the 3 identical special specimens were qualified. Example, 3 initial specimens passed at a DP50. Then you changed out the hinges on 1 substitution unit, but it only achieved a DP45. This would not be allowed or qualified or be able to be certified. And finally, section A2.3.8, no more than 3 substituted elements that are individually qualified by a single test shall be combined into any system. Nowhere does it state that reinforcement material can be substituted anywhere. Shown here in the NAFS equivalency bulletin, it states by testing to a newer version of NAFS that it qualifies older version of NAFS in most cases, except where noted. A version of this with NAFS 17 is in the works and the release date is yet to be determined. The NAFS equivalency bulletin allows a manufacturer to not have to test to all the older versions of the standards, which are sometimes still listed in the current building codes. This is a comparison chart of the differences between each year of the NAFS standard relating to what changed in each category as listed. Some examples of changes from the NAFS 05 to the 08 to the 11 are total number of product categories. It went from 30 to 31 to 36. The performance class used to be R, LC, HC, and AW. Those have now changed to R, LC, CW, and AW. Operational force requirements have changed for some of the products, and the cycle slam testing quantity of cycles has changed, and there's many other more. Please contact your WDMA representative for a copy of this if you do not have one. Shown here is the ASTM E1886-1996 bulletin, which is supplied by the third-party certification agency, WDMA. This states that by testing to the newer version of the ASTM E1996 and 1886 qualifies older versions of it in most cases, except again where noted. And you ask, how does this help you? How do these bulletins help you? Well, this allows a manufacturer to not have to test all the older versions of the test standards, which are sometimes still listed in current building codes. Again, for an example, this bulletin can be used on the Florida Product Approval System, When they ask you, if you upload your product and they ask you which test standard you tested to, you might have tested to an older standard, and then you can upload this bulletin and show proof of the validity of it. So finally, to the part that everybody's been waiting for, how to create the test plan. Well, here's an example template that's used at WDMA, and again, this is just an example for air water structural testing to fill out and submit to your third-party certification agency for approval. Again, this is only an example. There are many ways to assemble a test plan, just following all the information as previously shown in this presentation. So on this side, this is an example of an air water structural NAFS template, which is filled out for demonstrational purposes only. As you can see, the first unit here is a 60 by 96 double hung. The second unit is a 60 by 96 double hung with an aluminum plate mull in between it. This qualifies the mull per AMA 450 and testing the total assembly configuration, which is option 1 in the AMA 450. But again, it's only for the span and tributary width of that mold assembly. Unit 2 makes up for the 3 like specimens. So if you do the first unit and the second unit, all of those are identical units. That makes up your 3 identical specimens. Unit number 3 then is a 48 by 96 double hung mull together with a jam-to-jam tight mull. This qualifies per the AMA 450 option 1 again, mullion, testing the total assembly configuration. Again, only for this span and tributary width. Unit 3 was tested to get a higher design pressure rating. When you are completed with your test plan, submit it to your third-party certification agency for approval before beginning the testing at your test lab. This is an example of an impact test plan template. Could be used again for submission to your third-party agency. Again, this is only an example. There are many other ways to assemble a test plan. Again, just speak with your third-party certification agency on your format. And then here's an example of one filled out for a clad French push-out casement. Again, you can see here in the chart that most of the stuff is identical. The installation is identical for the first 3 units. The 4th unit, we're adding a different installation method with the screw-through frame method versus the initial structural nail fin on the first 3. The shape is a rectangle on all 4 specimens. It's clad for all of them. The glazing option is the same for all of them, and then the size is the same for all of them. Again, there's many options that you can choose from. If you wanted to do another option with hardware substitution, you would be able to do a 5th unit for that and add that to your chart, possibly changing from, regular hinges to butt hinge or something on your push-out casement. Again, when completed, submit this to your third-party certification agency for approval before testing. A manufacturer shall submit their product test plan to their third-party certification agency for final approval before starting their testing with their third-party testing laboratory. There are a handful of third-party certification agencies, with WDMA being one of them. So the final breakdown of the process is products are put into a test plan from fenestration product manufacturer. Manufacturer's product test plan is submitted to their third-party certification agency for approval. Then a test laboratory is selected and the products are tested by the third-party certification agency per the approved test plan. Final test reports per the test plan are submitted to certification agency or inspection agency for approval. Manufacturers must have a quality control program in place to ensure their products are built in the same way that they were tested. The manufacturer is to document or label these products to show compliance with the codes. And finally, a manufacturer is to maintain and control this process in order to stay up to date with the codes that are required. Thank you to WDMA and all who attended.